the #1 long-form writer that helps SEOs outrank competition at the click of a button using real-time research and NLP. Start ranking content today with content@scale.ai.
Wix Studio, one end-to-end web creation platform for your agency to deliver exceptional work with absolute efficiency.
Hello, everyone. Happy Friday. Who here's a little hungover? You can make noise. I need loud. I'm here to talk to you about LLMs and AI and robots and stuff like that. Hopefully this will give you a good background for the other talks coming up. So, I'm Jess. Hi. I do machine learning now. I used to be an SEO. Now I'm clustering data and things. I work for Local SEO Guide. We have a new website or something. And I'm here to bring you through some of the machine learning stuff I've learned so you kind of get what an LLM is. And I am going to have some audience participation, so I'm going to need some volume, okay? So my first question, who's sick of hearing about ChatGPT? Okay. Who's still super excited about hearing about ChatGPT? Okay. Who here doesn't know what ChatGPT is and is like, what? Okay, perfect. I don't have to explain anything. I'm leaving. So definitions. We're going to talk about machine learning, which is when you make machines learn stuff. Large language models. LLMs, which is when you take a large amount of language and use it in a model, and AI, which, you know, it's robots, whatever. So, again, we're doing participation. So we are going to become an LLM today. Everyone excited? So, what comes next? I'm going to say the pattern, and then you guys are going to say where the question mark is, okay? Pink, pink, pink. Blue, 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 green, green. Awesome, you guys are great. Perfect. Let's try a little harder one. Okay, everyone remember back to primary school. Blue, purple, red. Red, orange, yellow. Blue, green. Yellow, yeah. Some people remember primary school art classes, and some people do not. Okay, final one. Blue, blue, red, red, cube, yellow, 72, green. Nice tries. This is basically how an LLM works. This is what we call an out-of-context problem. When you train machine learning models, they only know what is in their context. So with the first pattern, it's very easy. It just kind of knows what the pattern is. With the second one, it is taking relationships between the different bits of data, and it is applying that information to different data. It knows the first and the third color make the second one, as do we all. With this one, the pattern isn't clear, because there really isn't one, and some of the parts don't make sense within the context. When a problem is out of context, machines really struggle, and so do people. So what was the point of this? Why did I make you do this? Why did I make you yell into your hungover neighbor's ear? The primary part of machine learning is something called, for text, is called tokenization. It's when you take bits of a sentence, turn them into numbers, and those numbers show you the relationship inside that sentence. So welcome to Brighton SEO. 1 is welcome, 2 is Brighton, 2 is 2, 3 is Brighton SEO. This lets us numerically create patterns. And that's basically what we were doing with this color guessing exercise. The pattern, the token, was the color. But if we converted those colors to numbers and understood underneath was text, we would be able to use that kind of pattern guessing as an LLM. It's a little convoluted. I'm really trying to be useful here. So I'm taking a detour into the word AI. I really don't like saying AI because I think it gives people kind of an inflated sense of what this kind of technology is capable of. You say AI, people think we are going to die. And maybe, but probably not because they're coming for us, probably because autopilot decided to drive into a wall, right? So this helps us avoid overhype. One thing I'm going to try and hit on is that these tools have limitations, and these limitations don't mean the tool is useless, it just means the tool needs to be used in specific ways. When someone says this technology is going to solve all of your problems, don't listen to them because it won't. Fundamentally, we want our bots to be helpful, and they can only be helpful if we understand how they work. So, how does machine learning work? In traditional programming, which the big nerds in the house probably know, every step kind of has to be programmed. If I am programming JessBot 5000 to walk across the stage, I have to say, okay, move the muscles in your thigh, lift your leg, move slightly, step down. Every step is programmed. Machine learning lets us show patterns to machines, and they can kind of learn themselves. So there are a couple of kinds of machine learning I want to go through here. This is an example of supervised learning. Supervised learning is when you give a machine a massive amount of labeled data, and you train the model on those labels. So I get a piece of data, I say, this is a cat, this is a dog, this is a pig, this is a goose. Put it all in a machine, it scrambles it up, and then it can kind of tell if something is cat, dog, or goose. Then we have unsupervised learning. And this is, I think, underutilized in SEO because it is something that lets us find patterns in unstructured data. And I don't know about you guys, but I spend a lot of my day looking at unstructured data. And then there is this middle point of semi-supervised learning. You take some labels and some clusters, and you kind of marry them. So a quick overview of how machine learning works is you get a bunch of data, clean it, scrub it, get rid of the stuff you don't like, make it fit, put it into a model, train that model, test it, find out it doesn't work, bang your head on a desk, go back to training, keep doing that. Eventually you get to deployment. Hooray. That's the exciting bit. This is more standard, this is your k-means, this is your easy mode machine learning, but we're going a little deeper here. I'm going to talk about deep learning, which is a very exciting, scary sounding word, and neural networks. I'm going to try and break this down for you. But one thing I kind of want to pull out here is sometimes you'll hear these systems referred to as black boxes. They're not as opaque as you might think. They tend to actually have explainability built in. Because how they tend to work, neural nets, is they are an attempt to imitate the human brain. But computers don't have all the organic mush that we do yet. So you take bits and you say, turn them into yes or no switches, and then you layer them on top of each other just over and over and over and over again until you get something that kind of makes decisions. But we're going to go even deeper than that and kind of look at some other types of learning. These can include reinforcement learning, which is like having a dog. You take your machine learning algorithm on a walk, and if it sits when you say sit, you give it a treat. You've got transfer learning, which is where you take insights or models from one type model and move it to another. Active learning, which is kind of like teaching school children. The machine learning model is school children, and they go, Miss, what does this mean? And you say, here you go, this is what it means. And then ensemble learning tends to combine all of these. Another concept is model fit. This is where your machine learning model, you kind of look at how it applies to that data. So you really want a balanced fit, because if you underfit, this is obviously bad. It's when you get your model all trained, you've got your machine, it has learned, and then it doesn't really work on your data. But overfitting is also bad, because it means it can only really apply to the data you use to train it, and that's not what actually we want machine learning models to do. Okay, enough of this. Why are you talking about all this nerd shit? I'm here to learn about ChatGPT. Well, we've got more nerd shit to get through, I'm sorry. There's no escape. Historically, we've always been trying to get to generative AI, which is when you make an ML algorithm that can generate stuff. It can make art, it can make text, it can make all sorts of cool stuff. But historically, these attempts have been lacking. I started doing SEO stuff in like 2015, 5 years ago, definitely. The pandemic didn't happen. And when I got onto the scene, Markov chains and creating content with Markov chains was like the big hotness. And I don't know if you guys ever audited a site that used these to create content, but the result was always garbage. In like 2017, a paper came out. It's called Attention is All You Need. If you like the nerdy shit of this talk, you should read it. It's a fun paper. But it came out with this infrastructure called the Transformers infrastructure. And basically, the Transformers infrastructure is a way to pay attention to different parts of a sentence so you know which bits are the most important. So I modulated my volume there because that's basically how it works, but with math. Tools, if you heard about BERT, I don't know if anyone heard about BERT. That was an early version of kind of transformer architecture in action. And so is GPT, generative pre-trained transformers. So now we've got all of this background. How do LLMs actually learn? We can put all of our bits that we've talked about together. They take a ridiculous amount of data, billions of pages. They clean it, scrub it, turn all of those words into numbers, and then look at the connections between those different numbers and learn patterns and relationships. This means these models don't have any sort of database. They don't have any sort of like factual background. It's basically like rolling a weighted dice. If I start a sentence with United, LLMs will have a weighted dice that say Kingdom, Arab Emirates, or States, and it will choose the most popular one. This means these tools have a lot of strengths and a lot of limitations, so I'm going to go over some of those. One of them that I've seen around is, and again, trying to hit hard on this, these tools don't actually have any data source. There is no actual data behind the things it says. So this is an example. I said, hey, give me traffic data for these sites. And because it is working off this statistical principle, it goes, yeah, I'll do that. If someone was writing an article that was like, traffic data for these sites, this is what it would look like. So you've got, it says Google gets like a couple billion per month, you know, all this kind of thing. This is all statistically generated. None of it is true. We don't actually know for several of these what is actually going on. But it wants to, and wants is kind of a misnomer, but it's trying to create the end of my sentence, whether or not that is correct. Another limitation that people see is these tools don't actually have logical reasoning. People kind of think, oh, it's a computer, it's got logic. But the logical reasoning is kind of limited. So this is another group of children's riddles I threw at ChatGPT. I said, what doesn't fit in these colors? Blue, green, yellow, and red. And going back to our primary school here, the correct answer is green, by the way, because it's not a primary color. But you can see ChatGPT was like, yeah, blue's not a primary color. Blue's the one that doesn't belong. Not quite right. And for all of these, it was not quite right, because it doesn't understand what words are, or colors, or numbers. It knows what tokens are and how they relate to other stuff. There's also some ethical implications. You can generate misleading, harmful content, sure, but people are using LLMs in critical systems. And when that happens, who's at fault when they inevitably go off the rails? If you're using it in a way that could cause harm to people, whose fault is that? There was a site yesterday that generated a obituary for a man who died, and it called him useless in the title of the obituary. And someone just posted that to their website, didn't think about it, just hit paste. And, people are kind of mad about it. There's also bias. And this can come about in multiple ways. You've got biases in everyone is like a white dude, which I'm a fan of some white dudes. I'm not mad about that, but like not everyone is a white dude, right? And then you've got biases in bias towards recency, or like the thing that is in the data set, which means if you're bringing in new stuff, LLMs are very bad at understanding and working with that new stuff. If a paper came out that was new scientific news, an LLM would be very bad at parsing and understanding the implications of that, because all of the connections it's made are different to that new thing. So some things you can do and think about when you are looking at using these models and other models in one of your systems as an SEO or a marketer, pay-per-click, whatever. You can look at exploratory data analysis. What does your data actually look like? You can clean your data, look at and think about what data is bad. One question I get a lot is, okay, why does ChatGPT train on like hate speech or like bad Reddit comments or reviews where they don't like my favorite movie? And the answer to that is, if it doesn't have that context, it can't work within those limitations. It needs to have the context of bad stuff to recognize bad stuff when that is presented to it. If you didn't know what, bad SEO was, you would not be able to recognize it in the wild. There's also crafting features. This is when you look at your data and go, what do I actually want to do with this data? So do you want to pay someone to build your own model? Most people here are using ChatGPT, I'm assuming, in some way or another. This is easy, but you've got to be careful. There are data security concerns, generalization issues. It's not optimized for your stuff. And sometimes it's good to try using models that are more custom fit to your stuff. It kind of lets you leverage your own insights and make stuff that's really cool. You can use LLMs for content generation. There are some ways you can actually use it to make your content better. Stuff like paying attention to intent and specificity and giving users what they came for are ways you can pull in good information using an LLM. But for stuff like working with user data or big data in general, LLMs are like using a bazooka when you want to use a hammer. It's better to just look at ways that you can cluster data and use that data yourself. So I've got 1 minute. I'm going to run through some of my implementation tips. Never trust the machine. This isn't it's going to rise up and take over thing. It's just like sometimes it's going to say bullshit. You can add layers. You can use APIs like the Copyscape API to avoid plagiarism, but you should have human eyes on your stuff. Don't trust someone who says that AI is going to fix all of your problems. Cure-alls cure nothing. things that will fix everything won't fix anything. Use APIs, specifically with ChatGPT. If you use the API, you have a lot more granular control over the responses, which makes it a lot easier to fit into your workflows. And understand your tools. Generally, if you're using an AI, you are using someone else's labor, millions of people's labor. They have worked. You aren't using a copywriter or people, and you may be contributing to misinformation. I have to go, but is AI a fad? Probably not. But if we think about the future of these things, we will be able to use it in ways that can actually be helpful. And that's my stuff. Okay, I have to go. Bye-bye.
Monthly reporting making you want to shove sharp things up your nose? Try Dragon Metrics, the all-in-one SEO software with mind-blowing reporting tools.